friction between two surfaces depends on the smoothness of the surfaces in contact. For instance, it is easier to drive a vehicle on the road instead driving a vehicle on the frozen lake. This is due to the difference in the smoothness of the surfaces between the road and the frozen lake. But to drive a vehicle on the frozen lake, you need different tires than the normal one, which increases the surface roughness between them. So it means a greater force is required to move the surfaces past each other when they are rough as compared to when they are smooth. Also, it is more difficult to move a heavier object on the ground than a lighter one, where the two objects are of the same material. If you want to get the feel that what I am saying, then try to move the big block of an Egypt pyramid. Is this not cool? Okay. Or on the other hand, you can try to push the car while its handbrake is on. That makes sense. Now let's jump on to the factors affecting friction activity 12.2. As you can see on your screen, this is brick, this is spring balance, and this is a rope which connects the brick with the spring balance. Now what you have to do is, well, tie a string around a brick, pull the brick by a spring balance. You need to apply some force. Note down the reading on the spring balance when the brick just begins to move. It gives you a measure of the force of friction between the surface of the brick and the floor. Now wrap a piece of polythene around the brick and repeat the activity. Do you observe any difference in the reading of the spring balance in the above two cases? What might be the reason for this difference? Repeat this activity by wrapping a piece of jute bag around the brick. What do you observe? Now you can pause the video and just give it a try and write down about your findings into the comment section. Or you can keep watching this video to find the answers. Now in the first case, we have seen that the brick and the floor is in direct contact, and due to the surface roughness of the brick and the floor, spring balance shows the measurement of the friction when the brick just begins to move. And now we are going to take this measurement as a reference. Now, when you wrap a piece of polythene around the brick, then you will see that the measurement of the spring balance is lower than the reference reading, which we took before. This is due to the smoothness of the plastic surface, which in results reduces the surface interlocking between the brick and the floor. But when you wrap a jute bag around the brick and then tries to move the brick by pulling the spring balance, then the measurement on the scale is higher than the reference reading. And this happens due to the fibers of the jute bag, as we know that the jute bag surface is way more rough than the bricks itself, which in results allows the fiber of the bag locks themselves with the floor, which causes huge reading difference on the spring balance. Now is the time to explain you what is spring balance. This is very important from the subject point of view, because we are using it throughout the activity from the topic factors affecting friction. Let me give you that information as well. The definition of spring balance is quite easy, and this is how you can define it. Spring balance. Spring balance is a device used for measuring the force acting on an object. It consists of a coiled spring which gets stretched when a force is applied to it. Stretching of the spring is measured by a pointer moving on a graduated scale. The reading on the scale gives the magnitude of the force. So this is your activity 12.2 from factors affecting friction. Now let's jump on to the activity 12.3 of factors affecting friction. So for this activity, you have to get some stuffs ready, which is easily available at your home. So the stuffs you need is a book, or you can take a wooden board, or you can use a chopping board which is available in your kitchen. But don't forget to ask permission from your mother. A cell or any cylindrical object, a piece of cloth, and of course a table or any type of plain surface or platform to place all these stuffs. So to perform an experiment, you have to place all these stuffs on a table, as you can see in the illustration on your screen. So here it is. Make an inclined plane on a smooth floor or on a table. You may use a wooden board supported by bricks or books. Put a mark with a pen at any point A on the inclined plane. Now let a pencil cell move down from this point. How far does it move on the table before coming to rest? Note down the distance. Now spread a piece of cloth over the table. Make sure that there are no wrinkles on the cloth. Try the activity again. Now you can repeat the activity by spreading a thin layer of sand over the table and maintain the same slope throughout the activity. So here are the questions arises at this point. In which case is the distance covered the minimum? Why is the distance covered by the pencil cell different every time? Try to reason why. Discuss the result. Does the distance covered depend on the nature of the surface on which the cell moves? Could the smoothness of the surface of the cell also affect the distance traveled by it? In order to find these answers, let me explain you. Friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appears very smooth have a large number of minute irregularities on them, as you can see on your screen. Irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surfaces, there are a larger number of irregularities, so the force of friction is greater if a rough surface is involved. So this explanation will help you to find the answers of the above activity. We see that the friction is caused by the interlocking of irregularities in the two surfaces. It is obvious that the force of friction will increase if the two surfaces are pressed harder. You can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. Have you ever tried to move a heavy box from one place to another place? If you have no such experience, then get experience right now. What is easier, to move the box from the rest or to move it when it is already in motion? The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. Or on the other hand, the force required to keep the object moving with the same speed is a measure of sliding friction. When the box starts sliding, the contact point on its surface do not get enough time to lock into the contact points on the floor. So the sliding friction is slightly smaller than the static friction, and you find it somewhat easier to move the box already in motion than to get it started. So this is all about the today's topic, factors affecting friction, activity 12.2 and 12.3. Give it a try for yourself, and if you still have some doubts, please let me know in the comment section. So what you have learned from today's topic? Here are some points which you should keep in your mind. The first point is friction depends on the nature of surfaces in contact. Number 2, for a given pair of surfaces, friction depends upon the state of smoothness of those surfaces. Number 3, friction depends on how hard the two surfaces press together. Number 4, static friction comes into play when we try to move an object at rest. Number 5, sliding friction comes with play when an object is sliding over another. Number 6, sliding friction is smaller than static friction. Now is the time to answer to the questions related to the topic. Here it is. Filling the blanks. The first one is, friction depends on the dash of surfaces. Number 2, sliding friction is dash than the static friction. What is the answer? You can pause the video right now and write your answers below into the comment section. Or you can keep watching this video to find the answers of the questions.